I figured this is probably the best way to uh, do a what am I thinking sort of process uh, to programming something and how to best describe what's happening. Um, and I'm cold, so you know. Okay, so today I'm going to be trying to think through how to program the process of doing. Well, let me try to focus. There we go. Of trying to do AI sort of jank. I say jank because it's not true AI systems. It's just making them walk around and have processes to make sure they get, from place to place and all the other little good stuff. So I have a few ideas in my head as to everything that I want to go into this, but let's just work through it. So, basic idea is you have a guy, somebody there, and then you want them to walk from point A to point B, and then from there walk to another point, and then either have them go back or maybe loop back to the original point, whatever you want them to do. What I want to get figured out is what they do, like what I should have them do in the transition process, or what I should have them do when they reach their destination, and everything sort of in between to get us to that point. Now, let's go ahead and erase this. So, to make it clear, the things I already have in my mind that are going to make this work are a couple things. First of all, there's the nav mesh, which, if you don't know what the nav mesh is, it's basically the it's on the map all the places in which it's basically already pre-built AI, but not quite AI. It's just where a movement pattern can take place. So instead of having physics-based movement where you have like a character that is placed on the ground, is stopped by the physics, and then you basically push them forward by momentum through physics to land on more physics stuff, which is typically how a lot of these things go. It's just you have a chessboard, and essentially you're moving things across the chessboard in a very fluid manner. So it gets real easy because what you essentially do is say you have one actor, which is a nav mesh agent, and here's the nav mesh essentially. Let's call it that. And just for reference, let's also call this part nav mesh as well. And you say, hey, I want, this is the point I want you to go on, which is usually the point we click on. And if you want, it'll basically just navigate to that point. The good thing about nav meshes is that if you have obstacles in the way, a nav mesh, since this is all part of the nav mesh, it will navigate across the nav mesh to get to the point you want to get to. Now, in, say, certain situations where there's another nav mesh point here, the good thing is nav meshes can also figure out how to leap from one to another. Not perfect. It doesn't always work. It's usually in like small bursts. If there's like small little islands here or there, that kind of thing, you can figure out how to leap it. But that's essentially the system we're working with now. So I'm going to take my blanket and ruin it. And then we'll go from there. So that's the basic mode of pretty much everything that moves in the game. And we move the main character by basically taking the screen position of the mouse, casting a line directly from the mouse to the point at which it is on the screen, and then wherever the nav mesh is, and then just saying that's the point at which we want to go to, and then the character will just sort of make its way there through that sort of way. So what I'm thinking is that if you have a character, we're going to basically set up what is essentially empty game objects. Okay, going to set up empty game objects in places that are just places where the character can go. Now, if you don't know as well, empty game objects are something that Unity provides, which is it's just a physical object within the game world itself, but it starts off as an empty game object because the only thing it holds before you put anything on it, before you put scripts on it, before you put models on it, basically everything starts as an empty game object. And then you add everything to it. Like a character model is an empty game object with the character model, all sorts of rendering data, all that kind of stuff on it. So it starts empty and then it starts. What basically an empty game object is all it holds is positional data and rotational data. And like I said, that's attached to everything because everything within the world has position and rotation. But this doesn't have anything attached to it. It's just positional and rotational data. And you can attach scripts to it. You can attach anything to them, essentially. But for this purpose, we just want positional data because it's just going to hold the positions of, where we're going to be sending these characters. Now, the other good thing about the nav mesh is that if you just tell the player or whatever character to, hey, navigate to this point, then it will just manage to make its way there. Same thing with every other one. So right now it's just one-to-one. You could just tell it to go to one point or another. You still have to program that. You still have to say, hey, this is the point I want to get to. But that's pretty simple. What I am trying to work out is what is the best way to link these all together to make it go, from one to the other to the other. Is there any pauses in between? How fast are they going to go? And a lot of interesting things comes with the nav mesh, which is a nav mesh also. The nav mesh also lets you figure out what you want to be a nav mesh agent and a nav mesh obstacle. Now, a nav mesh obstacle is pretty obvious. It's just an obstacle that you set as a nav mesh obstacle. Now, if you have obstacles that aren't considered nav mesh obstacles, it will still go through them because you haven't told them that, let's draw that nav mesh again, because you haven't told it that, this isn't something that you can't go through. Now, when you set up a nav mesh obstacle, you have a lot of different options for like distance at which you can stay away from obstacles, stopping distance from other things. So when you set up a nav mesh obstacle, essentially what happens is you're setting up a border around that obstacle that basically takes a hole out of the nav mesh. So essentially what the nav mesh looks after that, if you take out everything else, is it just creates a hole in the nav mesh, regardless of if there's anything there or not. So, with that in mind, the other thing we can do is with the characters themselves, nav mesh agent, those are the things that are actually moving around in the world. They contain data such as how fast the agent can move, of course, how slow an agent can move. It's got a few other things. I haven't played with them as much, but speed is the one that's actually really important for this one because, that's something we could play with if we want the characters to run faster or move faster. Yeah. So, starting out, so we have player character, and say we're going to have probably about 4 different points they're going to go to. Now, I'm drawing them like this because within the actual inspector element, there's something we have called, and my brain's farting on it now, it's an array. I'm sorry, it's an array. So an array is basically like how you have variables, which are, you can store variables as integer numbers, strings, which are just letters and full sentences and stuff like that. You can also set up arrays of game objects. And in this case, our game objects are just going to be the empty objects we had from before. So, when I create an array, it basically tells Unity that there's going to be an array of objects, an array, an assortment, all this kind of, when you think of array, you think it just in normal English terms, like you have an array of numbers. It's a large amount of numbers. In this case, you have an array of game objects, is a large assortment of them. But since these are just empty game objects, the only thing I have available to me is their positional and the rotational data, and their placement within the world itself, which is perfect because that's all I need. Because if I want to have all these things within the array, that means that the script I'm going to be creating has a reference to all of the positions that I have in here. Now, what this will take is, it could take a couple things. I can name these each individually something specific, like node 1, node 2, node 3, and then I can tell the script when it starts up, search for node 1, node 2, node 3. That could be good, but since I feel like there's going to be several different setups of nodes that we're going to be using for different characters, perhaps what'll happen is I'll just set up a blank array, and then I will manually insert each one into the inspector, so that instead of having it find it right off the bat without me having to do it manually, I'll just do it manually so that I have full control over exactly which nodes are going into that data. So once I do that, I'll have the positional data for this node, and for this node, all three of those. So I have 1, 2, 3. So I have those right now, but they're not connected. So here's what I'm going to think. I'm going to think that think of it in the simplest terms, like the player reaches node 1, then he can go to node 2 or node 3, or whatever order I want to put it in or program it into. I want it to reach node 1, 2, and then 3, and then, again, go back, go to node 1, whichever one. But two things happen in this case. One, because this is a very specific, so let's say X, Y, and Z, 1, 2, and 3. Say this is this isn't a reasonable position, essentially. But if you're taking a player, or especially on a nav mesh, and you're telling it to directly go to there, it becomes almost impossible to check when the player reaches this destination, because the manner at which the nav mesh actually has the nav mesh agent travel, it isn't exact. So if you're this is complicated, not too complicated to understand, but if your player's traveling and it reaches to this destination, first of all, the nav mesh has the ability to sort of slow them down, just sort of like creep them in, so that it's a natural slowdown of the player. It's a little more realistic, which is nice. It's great that it does all that stuff. The problem is that, especially when trying to reach a destination, it gets to the point where you're slowly ticking down from, like, so say if I'm trying to get to like X2 or like to X1 and I'm on X2, it slowly starts to creep down onto 1. And even then, if it overshoots it by even like 0.000001, or it stops right there, which is also a good possibility because of how inexact it is, it's never going to recognize that it has reached 1. Now, because it doesn't round down. Now, what you can do is treat it in a matter of just integers instead of floats. So when you have integer variables, they only deal in whole numbers, so 1, 2, 3, versus floats, which is like 1.0, 2.0, 3.0, and you can have as many decimal, or not as many decimal points, but as well, yeah, decimal point numbers as possible. And that's when you get something like this. Now, the complicated part comes in where even if you've reached the specific point, you still have the slowdown, you still have the problems with, you don't want it to be an exact point. It's the same kind of programming logic with absolutely anything. You really want to have the computer have a way to round up or round down, so that if there is this margin of error, you can correct it within the code itself. Let me think. Just to let you know, the jank I'm working with is my phone will only record about 15 minutes at a time, and then I have to upload it. It takes like 20 minutes. That's fine. Talking about, what was the last thing I was saying? Oh, so there's a problem with getting, if you wanted to trigger anything, say when you've reached, say you program something that says, when you reach this destination, execute code, blah, 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 whatever that may be. But that all is hinged on you reaching this exact destination, decimal point, and everything. And that's not always feasible, especially since positional data is stored as a float, which is always going to be a decimal point. I think you can still do it as an integer, but I think it's still unreliable in a sense where it's like you can't convert a float to an integer. It's just not an exact science. Or it is an exact science. It's not an exact execution when it comes to code. Anyway, so that is where you have basically trigger volumes, which is around this point is a volume. It could be a square, it could be a circle, which is basically a trigger. It's the same sort of obstacle code that you use for collision. It's collision detection, except instead of it stopping you from walking through it, it just detects when you walk through it. So in a sense, if you were to say create a collision detection around this, you could set up instances for when you enter, for when you exit, and also for when you stay in there as well. So if I wanted to say, hey, once you get to this point, you can execute whatever you want to, whatever this code is. So that means is that you have this whole volume to get to, instead of just this circle point right here, this exact dot, this exact number in the sense, or in the scene. You have this whole volume to go through, which is the trigger for all of this code, and it's predicated on, if you wanted to execute an enter, exit, or stay in there for, I think it's like, I don't know, it's a certain amount of frames for when you stay in there. But even so, that means that if you enter it and stay in this volume for long enough, it will trigger the code, instead of just when you enter it or exit it. So what you can do is, let's say your character's traveling along, it reaches this destination, and say your character's just sort of looks around, home down, like, oh, what's going on here, and then just moves on to the next destination. You would essentially say stop, trigger animation, and then move on to the next code. So that would be, you would, I don't know, you would say that you've essentially reached your destination, at which point the character will stop naturally anyways. And then from that point, you basically move on, say play the animation, which is whatever animation you have stored on there, or whatever animation that you set the code to point to for that character. And then from that point on, you then move the character by redirecting the the follow point, essentially, the place they're going to go to the second point. Now, that's where this becomes very handy. Is because when you're writing the code, if you're doing it manually, especially when you're doing it manually, you you don't necessarily know what each of these points are. So you can't just say move to I don't know. You can give them names, but you don't always know exactly what points they're going to be, because I can move these around constantly. I can move them to here, I can move them to here, I can move them to here, but it will always still be stored here as far as data. I don't know if I caught that. So no matter where I move this to, it's always going to be stored in this, which is always going to be linked directly to here. So if what was I even saying? So when you're programming, I have to make sure that I can say something like, I have to create, I could do a couple things. I could do it by cases, or like case 1, case 2, 1, 2, and 3, which is an actual programming. It's called a switch statement. The reason why I don't want to use those a whole lot is because, especially when it comes to optimization, the computer likes to preload a lot of stuff beforehand, which cuts down on load time. So if the computer knows the exact path, or if the processor, I don't know which part handles it, because physical stuff I'm not the best at, but essentially the theory is that if the program can preload all the processes that it's going to take, and it can link all the things together, it will do that ahead of time. Things with switch statements or even if statements, those are choices that are made in the moment, at which point the program doesn't load anything past that, or it doesn't recognize anything past that, so it stops. So say you get, you load the graphics, then you load the I don't know. What's a good example for this? I mean, obviously you load the textures, the rendered whatever, the models, trees, the train, and then you start off by your character is moving and it has the destination to move to. You move to that destination. It already knows that you. I don't know if it would work for when you enter. I think no. If this theory is correct, it wouldn't know when you enter as well, so it'll still stop there. But even when you enter it, it already knows that you're gonna stop. You're gonna play the animation, and then you're gonna select the move, or you're gonna switch the new position. So it already knows how to load that. And then you move on to the next thing. It's gonna go there, and then it's gonna know to stop, play the animation, load the move position. So it's these little chunks, essentially, that it sort of cuts out. It's the same thing with if statements, where it's like you have a whole bunch of code that's loading. You basically tell the program to load all the things on the awake, on the start. Here's your program, or here's your functions. And if you ever get in one of your functions something that says if else, essentially, which is just like, if this happens, then this will happen, that kind of thing, the computer won't be able to go any further than that for preloading it, because it's waiting to figure out which one's going to happen. A lot of times it's very unavoidable, but you want to try to minimize that kind of thing as well. That's extremely off topic, though, so we will. So here's my problem. I want to make sure that I can make sure that the player has the ability to move to the point, and then can move to the next point, and then to the third, and keep it in this order. Now, here's where the complex part comes in. And I'll be honest, I'm probably going to say that many times because, I don't know, my brain thinks like that. Let me erase this. But here is certainly a complex point. So you have scripts attached to the player. Certain scripts, like moving, I don't know, controls, camera stuff, whatever. You have certain scripts attached to the player. Now, when you're dealing with something like an empty game object with the bubble around it, this empty game object no longer is empty. As a matter of fact, it's got the positional data as well as it's got a sphere collider around it. So this is the now this empty game object now essentially turns into a collision detection trigger. I mean, even this can have collision detection as well, and it does. But this now has a component attached to it, which is a collider. So that's the script attached to this right now. Now, what we can do is this. We can choose to detect the collision through the player, or the player character, or we could choose to detect it through the point itself. The reason, up until this point, a lot of what I've done is I've made sure I've put it on, like especially with the camera, I've made sure to put the script onto here so that I can more directly communicate into the sphere collider itself, or any collider for that matter, what to do with the player character. Or I've mainly put it on here so that I can have better control over, when I'm able to activate something within the player character itself. So what's going to happen here is I'm going to want to make sure that, first of all, the sphere collider is able to access variables within the player character itself. Because what I want to do is I want to make sure that I want to make sure that I have the player character and its movement scripts have an open variable, essentially, that says something along the lines of sorry, I'm scrambled here now. Let's bring the piece of paper back up. So again, these are our points, right? These are our points that we'll be traveling to. This is our array with a whole bunch of different nodes for a whole bunch of different positions we're going to. Then I want to make sure that that this script is able to communicate to the player and to the array to say that you've reached the first point. Now we switched from the first point to the second point. So when the player enters the first point, we will then trigger it. And I'm thinking a little bit ahead here. We will then trigger that. Basically what we're saying is that we trigger the player's script that we'll have written for this event, essentially. It says, hey, you've entered this point. And we'll have this point numbered, or at least this point pointing to here. So object 1 in this array. If the player enters object 1, then we execute the script, which we already have stated is going to have like stop. That's supposed to be an S. Stop. Animation. And then move. So that means, here's the whole flow of it. Okay, I got it now. That means this one's going to trigger the player script directly. It's going to say, uh, let's just say that it's just an int. Let's imagine it's just an int. And then we can attach each one of these to be int 1, 2, 3, 4. It wouldn't be an int. Oh God. So it would be array. This isn't how the code exactly is going to look, but it would just be array 1. So we're going to say if array 1 is reached, then how exactly would this work? Look, there's a lot of inner monologue dialogue. Oh shit. There's a lot of things that goes on in my head that I can't really describe as words, which probably aren't even words. They're probably just, I don't know, screams. Okay, anyway, start again. Basically, what we're gonna say is that the move direction for the player is going to be triggered, or rather switched, by entering into here. So what's going to happen is we're going to switch from array position 1 to array position 2. But the actual switch doesn't occur until after the script initiates the move action to happen. So like I said, stop was the first one, animation, and then move. So what's going to fire first is it's going to make the switch, right? Or actually, technically, what would happen first is it stops. Well, technically, they'd fire together. I mean, honestly, even if they fired one after another, the difference in time between them is about a frame, if that. Even so. So it would switch. So what would happen is we switch from position 1 to position 2. That affects the next move command that happens. So stop, animation, and then move. And then we move on to the next one. And then we repeat the process for the next one, which is, switch it from like 2 to 3. 3. I even had to second guess whether or not that was the correct direction for 3. So then again, stop, animation, move. And it just keeps going on from there. So that's essentially how we're planning on. I mean, even if you took out, even if you took out this, if you just entered in, had it switch from 1 to 2, it would still just move on to the next one. So at the base, this is what we want it to do. If we wanted to add animations, if we wanted to add maybe the character stops and talks to themselves, there's a lot you can do with it, which is part of the thought process of this. But at the very base, let's break it down. After all that, here's what we got. Player has an array of positions. 1, 2, 3, 4. 1, 2, 3, 4. So, player is going to be at the very beginning it's going to be instructed to go to position 1. So here's position 1, and then it's an empty game object with a trigger on it, essentially. So it's a trigger. So they're going to cross into it. It's going to trigger to say, hey, switch from 1 to 2. Going to go down, and this one's go from 2 to 3, over, from 3 to 4. From 4, and I mean, honestly, we could instruct to go from 4 to 3, and then from 3 to 2, and from 2 to 1, and then from 1 to, I don't know, 0. I mean, again, you could have as many of these as you want to. You could even have them just loop throughout this whole thing. The point is that this is how we basically move them. Now, how are we going to structure this? Now, here's my thinking. So, since that's pretty simple, let's tackle a problem of if we wanted to go from 4 to 3 and, backwards. If we wanted to have it loop all the way through and then come back. So, if that was the case, What we can do is uh, this this might be the jank way, but we'll see. Um, each one of these triggers is essentially its own script. Now, what I mean by that is they each have their own script attached to it. It's going to be the same script in which you write a script. It has all the code in it, and then you can essentially attach a version of that code to each one of these things. Now, that code can have things like, I don't know, it can have its own bools, it can have its own switches, it can have everything on its own, but it's applied individually to each one of these, and you can set them up individually for each one of these. Now, we could go through the process of trying to manually put that in. Yeah, as I said before, you could just sort of drag and drop into the inspector all the points that you want done. But I originally described this code as simply switching from 2 to 1, or 1 to 2, 2 to 3, 3 to 4, so it's not as easy as just dropping them in if you want to keep by the code. So essentially, what we're going to want to do is have a way for the code to switch whether or not it's pointing for it, whether or not it's counting up in the array or down in the array. And we may not even have to directly be just like counting in the array, although that would be kind of nice. Anyway, so what I'm thinking is maybe do just like a bool switch, which means just a true or false switch, essentially, which can be done a couple ways. I'm thinking as you enter the script, it will switch it from 1 to 2, and then as you exit the switch, it can switch its trigger from 2 to 1. So when you exit this, okay, well, that doesn't make any sense for this one, because essentially, let's just imagine it's, well, you know what, let's not. Say that this is 1. Just make my life easier. Whatever. Fucking kill me. Anyway, so let's just say that on the enter, it switches it to the next one, and then on the exit, it tells the script to basically switch it around so that the next time you come into the script, it sort of switches it back. Now, what that entails is, oh, hold on.